Hello. In this video we will study the turn-off methods. In the last video we discussed turning off mechanism. Now we will see turn-off methods. So in the last video we discussed that you can turn off an SCR by bringing anode current less than holding current and remove the excess charge carriers from outer junction layer and remove the current which is trapped in inner junction from recombination. So now that mechanism we have studied. Now what are the techniques or what are the methods we use to turn off the SCR, we will see. There are two types of commutation techniques. So turning off SCR is also called commutation. So we have two types of commutations. One is called natural commutation, another one is forced commutation. So in the natural commutation we use alternating current. See how we can reduce the anode current below holding current by applying a reverse voltage. Okay, by applying a reverse voltage across SCR we can reduce the anode current. So in alternating voltage what happens, the waveform or the voltage will swing between a positive to a negative maximum to positive maximum. So it will be in both direction. What happens when it is in positive or during the positive cycle, your SCR will be turned on. During the negative cycle, naturally you will apply a negative voltage and SCR will be turned off. So this is called natural commutation. It is very simple. If you are using AC signal, it is very easy. But when you use DC, we can't use this technique. So then we will go for forced commutation. So in the forced commutation, what you have to do, we have to use some external circuit to bring back your anode current to below holding current. Okay. So there are many forced commutation techniques, but we will concentrate only one technique, that is called class A, commutation by resonant loading. So this is the one technique we are going to study. Class A commutation by resonating load. So in this configuration is like this. We will use LC component in series. Okay. So you can see this is the supply SCR. We will use L and C we will use. In one configuration we can use RL in parallel with C, or you can use RL in series with this one. So you can use either. Okay. So what is the objective of this one? The response to the DC input, the response of a circuit to the DC input depends on what components you are using. Suppose if you are using in your circuit you have only resistor, means you will see how you change the input voltage. Similar way your voltage across the component also will change. What I mean is, so if you connect a voltage and you use two resistors and you want to measure the voltage here, so if you apply a DC voltage here, you will get the same response here also. You will get the same, but it will be divided, voltage will be divided. So there will be, the circuit response is very easy, very simple here, because you are using only R. But when you are using LC within your circuit, then the response of the circuit to the DC excitation will be different. This you will study in detail in the next semester, that is circuits and control system. So there you will study. So in that we can choose the LC value such that the response of the circuit to the DC excitation can be an underdamped response you can have. So that means the current you can show here. So when you excite or when you apply a DC voltage to a circuit which consists L and C, you can have a response like this. The current in the circuit may change like this. It is called underdamped oscillation. There is a oscillation, means there is a variation in the output waveform, but it is underdamped. Underdamped means, so the amplitude of this one is reducing. So you can see here, this amplitude is reducing. This is called underdamped response. Okay. So what technique we are going to use is, in underdamped response, we can see the voltage is swinging between what? Positive and negative. So high and low, you have both here, both direction. So since we are using only DC, in AC we can achieve easily this positive and negative, and we can turn off SCR very easily. But now we are using DC supply. How we can have this kind of variation, that is positive maximum, negative maximum in our circuit? That is nothing but use LC component. So your response will automatically will have this kind of response, that is damped oscillation. So there will be variation and it is damping, because our intention is to not oscillate. Intention is to, we should have a current or voltage waveform such that you will have maximum voltage and minimum voltage, that is in opposite direction. So voltage changes in either direction, that we want. Okay, so that's why what happens here, when you apply DC voltage, initially the current flows. If you apply a gate trigger, the current flows. When current is flowing, your capacitor will charge. So when capacitor is getting charged, the voltage across anode cathode will decrease. So it will reach a state where the holding current will be less than the, anode current will be less than the holding current, and SCR stops conducting. Okay, so that is what happening. You can see here. So at this instant of time, if you apply a gate trigger, so here you apply a gate trigger, then SCR starts conducting. So FR start conducting means what happens? Voltage across SCR will be 0. That's why voltage VSCR is 0. And what happens? Current starts flowing. Current starts flowing. When current is flowing, what is happening is the capacitor also getting charged. So you can see here, capacitor is getting charged. When it reaches a maximum value, then the voltage across SCR will be less. You can see voltage across SCR is voltage this end minus voltage at this end. Now this voltage is increasing, capacitor voltage is increasing. So what happens? Voltage difference across SCR is reducing. So when it reaches maximum, your anode current will not be greater than IH, then it stops conducting. So when it stops conducting, you can see there is no current flowing through the SCR, and your voltage across SCR will be high, because it is act like a open circuit. It acts like a open circuit. So VSCR will be nothing but the V in. So voltage across SCR is nothing but the EDC itself. Okay. So that's why here you don't get any current, and voltage you will get a what voltage, the whatever input you have given, same voltage you will get. Again, if you trigger the circuit, same thing repeats. So you can see here the voltage across the, when FR is not conducting, the voltage across the capacitor, that is discharging, and it will reach to 0. Okay, so that's why current will decrease through RL. Load resistor is used to discharge the deposited charge in the capacitor. Okay, so that is what you will get response. So how we are turning off an SCR, though we are using a DC voltage? So you use LC component and create a situation such a way that when a DC supply is applied, a current or voltage is generated which will have this shape, whatever shown here. This shape of current you will generate. So once you generate this kind of a waveform, why it responds to this you will understand in the next semester. Why when L and C are there, if you apply a DC input, the response of the circuit will be like this, that you will study in the, now you assume it will have, it can have this kind of a waveform. So then what happens, a reverse voltage can be generated across SCR in the DC also, and you can turn off the SCR. So that is how it, what is how you turn off by resonating load. Okay, thank you.